The height of the ball in feet varies with the time and is given by this function, where t is the time in seconds. What is the maximum height of the soccer ball to the nearest foot? So we're looking for the maximum height. And as I point out from this equation, height is here as h is in the place of y, and t is in the place of x. So y is height, and t is time. And x is time. And I point that out because the number one way people miss this is by putting the x value, which refers to the time rather than the height. Well, what we could do is use our tools. We could just go graph this and look at the maximum. So I'm going to go to new document here, and I'm going to look at a graph, and I'll type in the equation. It was negative 16, and instead of putting a t, we'll put an x in its place, x squared plus 33t, or in this case 33x. I hit graph, and there's the graph. We're going to look for the maximum. So we're looking for this highest point up here. Menu, the way you do this, you go to the menu, analyze graph, and we choose maximum. It's going to pull this up, and you put it on the left and press enter of the maximum, and then on the right. And so that's our maximum, and a maximum occurs at 1.03 comma 17. So since the max occurs there, 1.03 comma 17, we now say, what's the maximum height? Well, the height is the y value. So this is our answer there. The answer should be 17. So other things they could have asked that would have made the answer different is it could have said, what time does the maximum occur? That would be this. They could ask, how much time does it take for the ball to reach the ground? In that case, we would have done something totally different. We wouldn't have looked for the maximum height, but rather we would have come back here and analyzed when it hit the ground there. So those are different ways they could ask a problem like this on the test. Just be ready and know that you work from the graph.